Hey class, I finally got a document camera, so I'm going to show you some of the graphing techniques in 2.6 and 2.7. I'm going to put this thing down and kind of we'll see how it goes. Okay. Okay, so let's talk a little bit about 2.6 and 2.7. Kind of see how all this works. So let me just kind of title this thing. I hope you can see that okay. There are basically four types of base graphs that we're going to be talking about. There's your quadratic, there's your cubic, there is your square root or your radical, and there is your absolute value. So let me go ahead and write those in. This would be your quadratic, which is what we call a parabola. So this is your f of x equals x squared, which is your quadratic. This guy has a domain from negative infinity to infinity, and this guy has a range of bracket 0 to infinity. You can notice that the point here is a point 0, 0. So notice that that's essentially what we call the vertex. But we'll get to that later on in chapter 3. That would be your quadratic. Sorry, my lines aren't exactly straight, but hopefully you get the idea. This is your cubic. It looks like a little propeller. And again, notice the point 0, 0. Notice how it also passed through the point 0, 0. The domain would be negative infinity to infinity. And the range would also be negative infinity to infinity. This is your, like I said, your cubic, which is x to the third, your cubic function. Notice this guy looks like a little propeller. It's symmetrical diagonally. This guy has symmetric with respect to the y-axis, but again, that's not important. What's important is how they look, because it looks like a happy face. This guy looks like a little propeller, a cubic, and you have, in no particular order, the next one, which is your radical function. Now this guy just kind of, it increases slightly. It goes upward from, again, notice the point 0, 0. So these guys kind of slowly, gradually getting bigger. He is your radical function. His domain would be, again, all the non-negative numbers, so 0 to infinity. And his range would also be from 0 to infinity. The fourth one, again, like I said, in no particular order, again, sorry for the non-straight lines, is your absolute value function. He's a little v. He is your absolute value function, which you learn a little bit about the inequalities in chapter 1. So again, like I said, let me put it down here. He is the absolute value function. Now his domain, or its domain, would be negative infinity to infinity, and his range, his range would be 0 to infinity. So let's hope you can see that. Let me see if I can kind of zoom in a little bit here. Give me a second. So I can get more of the picture in here so you can see everything. See how this works. Give me a moment here. Still trying to figure out the nuances here, so just if I can get more of the picture. That might be a little bit better. Maybe this is a little bit better. There we go. A little bit more here. Let's see how that kind of works. Sorry for the movement. Trying to get this a little organized for you. So these are the 4 base graphs in your quadratic. He's kind of like your happy face, which they call a parabola. This guy, he's kind of like half above the x-axis, half below the x-axis, kind of like this one. Notice that they both go up from the right side, but this one reflects downward, the left half. So they're similar, but they all pass through the point 0, 0. Notice again, 0, 0. They all pass essentially through the origin, which is an important fact because this is the point that we're going to use to do the translations. So in essence, there are 4 translations. I don't want you to get caught up in formulas, but let me give you an example or examples of translations. Of these base graphs. So example number 1, let's say f of x, let's say is equal to x minus 1 cubed, where it's, notice it's inside the parentheses. So what we're trying to do is trying to figure out this 0, 0 point here, because the x-axis, the x is fixed at 0, I'm sorry, and the y is fixed, what value can we plug in for x to make all of this equal to 0? Well, the only answer would be the positive version of this thing. Opposite sign of -1 is a positive 1. So when I plug in a 1, I get a 0 for y. So essentially, 0, 0, what used to be that point before, now kind of moves. It moves to the right. So in essence, if I can here, and if the picture doesn't come into focus, I'll do it in a second. The point that was 0, 0 now moves to the point 1, 0. So in essence, this graph moves over 1 spot to the right. So at this dot is now this dot. So notice to the right of this dot, it goes up and to the right. So up and to the right some amount. Exactly how wide you make it doesn't matter to me. Where it crosses the y-axis doesn't matter. Just want you to understand that this graph is that graph moved 1 unit to the right. So 1 unit to the right. That's what what's minus 1 means, essentially. Now, if you take a look at plus 1, in this case 0, 0 now moves to the point -1, 0. So this means 1 to the left. So in essence, 0, 0 becomes now -1, 0. But the graph is still in the same direction. So notice they moved original. I say, hope I don't mess you up here. But this is f of x equals x cubed. And this is f of x equals x plus 1 cubed. Try to squeeze it in there kind of small. I don't know if you can see that or not too well. But in this one, the original one was like this. of x equals x cubed, cubed, and this one is f of x equals x minus 1 cubed. So in essence, inside with x, minus means go right, plus means go left. So as we do this, at least you know minus means to the right, inside, plus means to the left. So that kind of takes care of that. So let me go ahead and turn the page here. So I can kind of write on the back of this a little bit. As you were, as it is, example 3. Let's say f of x equals the absolute value of x plus 1. And example 4, f of x equals the absolute value of x minus 1. In this particular case, plus means up 1, minus means down 1. So in this one, the point 0, 0 goes to the point 1, goes to the point 0, 1. Up is with the y value, down is with the y value. So essentially, the bottom of the v, which used to be 0, 0, now goes to the point 1, 0, 0 down to negative 1. So plus on the outside of x means up, minus means down, so that affects the y value. In the previous one, right and left affected the x value. So the x left is positive, so it's weird because it's opposite sign. And negative is 1 to the right here. Negative 1 means 1 to the right, so the x value gets affected. This one will affect the y value. So ultimately, again, noting that the absolute value function is a v, essentially how it works out, 0, 1 is here, up 1. So this is the point, this is the graph, f of x equals absolute value of x plus 1. It should probably be more symmetrical, and I probably didn't make it wide enough here, but hopefully you get the idea. Or again, original, this is f of x equals absolute value of x. So you see how it goes up 1. Now down is very similar, but just obviously means go the other way. So go down to negative 1. And honestly, how wide you make the v doesn't really matter to me. I'm sure in the computer it'll make it more to scale. But for me, the wideness of the v doesn't matter, just as long as you get the point. So f of x, the point of the shifting of the shifting. So this is down, and this is up. So positive on the outside of the x means up, and negative means down. So it kind of, it all depends on the 0, 0. See, it all moves. So up and down will affect the y value. Left and right will affect the x value. So it kind of tells you where that new point's going to be. I like to call that point the critical point because it kind of anchors everything. Okay. So let's look at a fifth one here. Again, I'm going to use y. Essentially, I want you to note that y and f of x are essentially interchangeable here. Kind of mean the same. Now later on, under certain restrictions, they don't necessarily mean the same. But here we're going to note that y is a function of x. So we can use the y notation or the f of x notation. So I'm going to use them both, but I think the computer tends to use f of x. Y is also used in the textbook, just so you can have that. So let me see here. I'm sorry, let me change this. Let's put a number in front. What the y kind of does, it kind of makes it twice as steep? It means the y value will double for every x, which means essentially it goes higher, faster. But I'm only doing this because the computer is showing you. It doesn't matter to me. So for us, if this is y equals the square root of x, then notice here, there is no left or right change. There is no up or down change. So notice 0, 0 goes to 0, 0. It stays. It doesn't move horizontally. So the x and y values stay at 0, 0. The only thing is, it'll be twice as steep. So the y value tends to double. So for me, it doesn't really make a huge difference. It's just going to go higher. Now, if it's 1/2, it'll be 1/2. So like if it was 1/2, for instance, it would be like here. But it's not important to me. I just want you to understand that here, notice, if I can spell correctly, notice, same direction as base graph, meaning it goes in the same direction and it starts at the same point here at 0, 0, so that doesn't get changed. But now, if you put a negative in front, even if it was 2, you see, these values here are all positive y values. If you multiply positive y values by a negative value, the y values become negative. So essentially, this negative means reflect or flip about the x-axis. So let me show you what that means. So where, again, this is y equals the square root of x. This would be y equals negative 2 square root of x. So this is your flip, so to speak. So essentially, over here, positive, no flip. Negative, flip. And about the x-axis. So those are your movements. Those are your translations. Again, let me repeat that again. Again, your quadratic, your cubic, your radical, your absolute. Within the x parameter, negative inside with x means the opposite direction horizontally, which means positive. So negative moves to the right, positive with x moves to the left. So that's where the 0, 0 moves. Positive outside means the y value moves up 1. Negative outside means the y value moves down 1. When you multiply the function by a number, positive means no flip, same direction. Negative means flip. So let's try a couple of examples where all of this is together. Okay, a second. All right. So as it is here, this would be, I guess, example 7. So let's say y equals negative 2 x plus 3 squared plus 1. So this is your quadratic. So loosely speaking, it's a little happy face. It's kind of loosely speaking there. Let me see if I can. Okay. This means flip. This means left. This means up. So left for the x value is -3, up is +1. So this is what I'm going to call the critical point. So 0, 0 moves to -3, 1. So in essence, I'm going to find the point -3, +1. I'm going to put a dot there. Now that dot represents the bottom of the original. So that dot is this dot. So because there's a flip, this happy face becomes sad. So because it flips, so happy becomes sad, this 0, 0 goes to the point -3, 1. So what this function is saying is, take the happy face, take the 0, 0 on the happy face, flip the happy face, move the dot move the lowest point to -3, 1, and then draw your picture. That's all that is. Let's try another one. Y equals 4, absolute value of x minus 2 minus 3. Again, for all intents and purposes, it's going to make the v more steep. But for us, all that matters is it's not going to flip. It's going to magnify it by 4 times. These bars mean absolute value. So in your mind, you know it's going to be a v. You know that's the point 0, 0. This means opposite of negative means to the right. Positive means right. 2. This means down. So inside means right or left. Opposite sign, so it's right. This means up or down. Same sign, so down. So the point 0, 0 moves to the point +2, -3. So we're going to go to the point 2, -3 and draw that dot at this point and draw V because there's no flip. So that's all this is. So x value is +2, y value is -3. Again, where you cross the x and y axis, to me, it doesn't matter. The My Math Lab will have it more direct and it'll tell you exactly where to pass. So when it gives you the choices, you could figure that out on your own. Okay, let me do one more here for completion. Let's say f of x equals negative x minus 4 cubed, I don't know, plus 2. This negative means flip. Negative means -1. That's what it stands for. So that's like an invisible -1 there. So it means flip for sure. This means to the right. This means up. So the point 0, 0 is going to move to the right, and it's going to move up. This is your quadratic. So this is this guy. But now, when you flip a quadratic, when you flip the cubic, it's going to flip in this direction. Because this bottom part's going to come down, and this top part's going to come up. So it kind of flips in that direction. It flips it vertically. Okay. So I'm going to go to the point 1, 2, 3, 4 to the right and 2 up. I put my point right here. But now instead of me drawing it like this, I can't because this is a flip. So this left part is going to go up, this right part is going to go down. So it's going to look like this. Sorry, so this left part is going to go up, this left side is going to go down. And that is how you do this. And I hope this explains more. I'm going to go back to the original 4 graphs really fast. And I'm going to show you here. I'm going to show you here in red. This means flip. This means flip. Again, flip is just a way of saying reflects about the x-axis. The flip, the bottom's going to go up, top's going to go down. I'm sorry, the left is going to go from the bottom to the top, the right's going to go from the top down. So that's your flip. The V is going to be an upside down V. So that means flip. I hope this video helps you a little bit. So I'm going to go ahead and stop it, and I'm going to upload it, and I'm going to send it to you. So hopefully this will make more sense.